So I have on the call today Houssem, and he is working on. Actually, why don't you introduce yourself and then introduce what you're going to demonstrate and show here, and then we'll just discuss this and just kind of talk casually throughout it.
Absolutely. Yeah, so my name is Houssem. I've been working as a game dev for about like 2-3 years now professionally, and yeah, I kind of stumbled on your video and kind of encouraged me to go back to one of my projects where I tried to like find a solution to hook into Unity and actually get true hot reloading, like without like the spamming of no refs, losing static refs, etc. So yeah, after like I think 2-3 days of tinkering and stabilizing the project, I got something working that might give other people a clue of how to start their own like solution to handle hot reloading, stuff like that.
Okay. Yeah, if you just want to start guiding us through it and show us how it works, what it does.
Yeah. So I don't know if you can see my screen here with like the info text, null interface 1, interface 2. It's just
Yes.
like a small testing scene. So I'm gonna open the script here, which is like basically a testing script that I use like, to see if like actual like interfaces and fields are being like reloaded.
Okay. Would you be able to zoom in just a little bit to like
Yep,
maybe?
absolutely.
Thank you. Perfect.
Good. So basically, the proof, like to show that we're actually like reloading stuff, is pretty much like in this interface iText message, which is basically something that like takes in this like example. I'm just like calculating ticks. It just like spits out a simple message like this string is coming from the interface X, just like pretty much to show us exactly that the output is coming from the interface itself. It's not like there's no like trickery going on over here. So there's also like another static field just to taste like the how to reloading of static stuff, and this is like a attribute to mark an attribute. We can go back into this later just to explain the solution that I did, because it's like as you can see here, it's not something like provided by Unity or something. So UI, some non-serialized fields. These are like private float, not marked with serialized fields. So it's pretty much not going through the Unity serializer. So these two fields, of course, this one, since it's an interface, shouldn't be serialized. Same thing for the static thing. So the only thing that's serializable here is this UI text reference. Okay, so in this update loop, pretty simple, just counting the seconds since the start of the game and just showing and just assigning the text. Like we get the text through the interface and we assign it to the UI. So technically, if the text message like thing is null, we're gonna get the interface field is null. Else, we're gonna like take this like string that we get directly from like these two classes that inherit the iText message. So I guess these are like just like methods to link them to the UI to make stuff easier. Just to assign null, assign like the first type that gives us a message and the second type. Just like some methods to link to the UI. So I'm gonna start to see now. And you can stop me at any time if you like want me to go into explaining something. So as you can see now, it's null. I switched to interface 1. It's just like pretty much a counter that's ticked like on update. Here it says hi. This is an output from interface of type text message 1. Now we're using text message 2, null, etc. So I have here a small settings thing that's like related to solution, just to make like recompiling easier. It's just like triggers like a recompile.
Oh, it was fast too.
Yeah. So as you can see now, we recompiled and it still kept the data along with like the static field. Just like I'm gonna just reload manually here to prove like that there's no like trickery going on. Just to reload, re-import, sorry. And as you can see, it's keeping
It
the
kept
values.
nice.
Yeah. So since like we've seen here that's actually working, like oh yeah, another thing, because I think I like I tried to see like to follow like the episode like, where like you try to explore like solutions for hash reloading. There is no overriding here, so like no, I think you use the serializable callback receiver, like so just yeah. This doesn't use it. It's like well,
Okay. Yeah, go on.
yeah, I just want like to add like this isn't like something that you add to the classes. It's just like a solution that wraps around Unity itself and just like does the work. So yeah, just to go into the, like first, I don't know if you have any other like question about what's going on now or
Not in
any
specific. I mean, how the serialization actually works on this one. Then, I'm assuming that you're doing something like, well, like yeah, like initialize on load, where that's calling it, and it's going to store all the static information into something that Unity can hold on to. But I'm curious as to how you're accomplishing it in specific.
Okay, so the main things are basically like these two events. I think I mentioned that like in the comment under the YouTube video. These like basically events that like the Unity editor like sends before assembly reload and after assembly reload. So these are basically the 2 points where like we intervene to, let's say, do whatever you want, like to keep the data.
Oh,
so the whole yeah. Actually, like found these out like just while like scrolling the documentation, and they seemed like pretty interesting. I guess I think now like with the new Unity stuff, I think after 2019, there's like a Unity editor compilation pipeline. Yeah, here we have like a whole lot of new like assembly reloading like related stuff that's been added just to make stuff like easier.
Oh, that is nice. This is definitely useful to know.
Yeah, of course. Especially there, yeah, when you want to like to do this kind of stuff. So yeah, you have like compilation started, ended. For me, I just like wanted to detect like the assembly reload and just come in and introduce my solution. So just to go briefly into it, what I basically do is like on this like before assembly reload. First, I do a few checks. Like for example, I make sure we're not like entering play mode, because basically we won't need like to reserialize anything. Some like settings stuff like if we're enable, if we're in debug mode, just stuff like to make sure that do we even need to like serialize the data of the scene. So if it's true and we actually need, then the whole idea is before like serializing, before like recompiling everything, we take a snapshot of the whole game state. By the whole game state, I mean scenes and static values. That's basically like what Unity is like concerned about when it comes like the state of the game. So I'm gonna go over like the lines one by one just to like kind of explain. So what we do is like these are like some serialization settings. Oh yeah, another like key thing like related to this solution is having your own serializer. And this might be like really like the biggest, let's say, hurdle when it comes like to solving this is like, okay, there's like first there's a lot of great serializers already available. Why use your own serializer? And what are the benefits? Even if I like, let's say, make my own serializers, what would I gain from this if it's gonna work like same like the other ones? And the thing is, Unity objects work in kind of like a unique way. They don't really like respect, let's say, C#'s like typical like normal classes. The lifetime is kind of different. They're kind of like almost like a handle to communicate between like the C# representation and the C++ representation. So they're not really like normal objects, let's say, for C#. So we need to handle them like in a special way, especially when it comes to serializations, because for example, when I like, because I don't know if you like use Newtonsoft JSON serializer. Yeah, because that's like the first thing I wanted to do actually. Like I was like, okay, we already have like a great serializer that's like pretty much standardized for C#. We can customize a lot of stuff. But the thing is, when it comes to like especially what is it called? Like hashing. If you're like using like dictionaries, if you're using hash sets or anything, the serializer by default uses the toString method, like of any object to compute the hash. And you can't actually override this. So when it comes like, if let's say you have like a dictionary of game object to int, the key of the actual game object would be like literally be game object dot name. That's what it's going to use as a key, and you can't override that. There's no like custom behavior you can inject in to actually use like get hash code or like do like your custom stuff. So that was really
Actually,
like problematic.
The Newton stuff does have a way that you can put in. So when you have like types like dictionaries where you have one type to another type, you can put in a special serializer object where you basically construct something. I don't remember exactly how it works, but I've run into that exact issue with it before. That being said, by all means, please go on with your solution, because it's working.
Yeah, but I already tried that, but it doesn't respect that rule when it comes to hashing. That's the thing. If you want to like to use a certain class as like the key or like in a hash set, it like bypasses that rule and directly goes to the toString. And that was like the frustrating part. I don't know if I missed something, but I read in the documentation, like I read that part in the documentation, and apparently it's like set in stone, from the API API side.
It's been a while. It's been a while since I faced it, so I this might not be the exact same issue, particularly with hash tables, as far as like putting in statics, or not statics, but interfaces and different things like that, where I had to put in special translate or serializing.
Yeah, I remember like for example, because I already like tried to implement this with the Newton soft with like since like vector3 class has like the property normalized, right? When like it gives you like the normalized vector, and since like it returns like a vector3, like the serializer keeps going into the property, and it like causes like an infinite loop, because it serializes like the normalized, it gives you vector3, goes into that vector3, finds another like normalized like property, goes into that, and like so on and so forth. There's like what you can like avoid that issue with like a custom converter like in Newton soft, but yeah, it's mainly like the hashing that really like made me want to like go into like a custom serializer here.
Okay. Yeah, let's. You want to start diving into it? Create game state snapshot, as I assume, where it actually starts generating.
Yeah, and this is nothing special. We just like I create the object, which just like contains a list of game object data, which is basically the scene data and the static data. That's what I consider a game state snapshot. And for the object is like basically the info we need to trace back the component or like the game object, specifically the component. So this is basically like how I save components before the scene reloads, excuse me. So scene path, game object name. This is just pretty much for debug purposes, not really important. So like the scene game object path, I think this would be like, I'll try actually to go into the file, because I think that would explain a bit more what I mean by that. So this is what I mean by that. So I'm gonna take, let's say, an object that we can see here. I'm gonna counter. So yeah, there we go. Sorry. There is counter. Cancel. So what I save here is like the path to the object. I don't know if you can see these values in the list.
Yeah.
Like 2, 1, 0 is like basically like here. This is like 2, 1 is like it's like basically their place in the scene. For example, just like indexes. It's like basically the indices to actually track a certain object. For example, for this like interface 1, it would be like 2, it's like the second object, then go
0,
into
1,
to
2.
scene.
Okay.
Yeah, pretty much. Just like how to traverse the tree of the scene to find this object.
Okay.
And what else? The component index, where it is here. For example, for counter, it would be like index 1, just like it's like the second in the list. Component type is just like the type of the component. This would be like hot reload behavior test.
Okay.
And
So
the actual value.
So is your code getting the actual like mono behaviors that are part of Unity, like rigid body, for instance?
No. And this is actually I'll show you like just a small, quick way of how like I avoid to serialize this kind of stuff. So the serializer actually has like a pass where I take like the type, I filter all the properties, and I can like set custom filters to define, like to say, oh yeah, like yes, we serialize this. No, we don't serialize this. Yes, we serialize this, but in a custom way, etc. So there's like a filtering process. So for Unity component, for example, I have this list of like all these like obsolete, I guess, either obsolete or something that we don't want to serialize ourselves. So like the old obsolete properties like rigid body, light, animation. These are like the stuff that you find on component by default. So what I do is basically like whenever I have like a component that I want to serialize, like I do like a quick pass over the type and I like remove all of these pretty much. So like I just remove them and then like pass them to the actual serializer to take care of what's left, in terms of properties. So when I come here like to component value, for example, as you can see, you don't have like any of the other stuff that we don't need. We have like here the type. This is like a special, let's say, special property that just like defines the type to help the serializer know what object are we traversing at this point. So just saying, okay, this object's type is hot reload behavior test. So like moving forward, like treat this object as if it's like of this type. So as you can see here, I have like count label, which is like a counting label, which is, let me go back here quickly. Yeah, it's like the UI thing. So it also serializes the Unity stuff, by the way. Okay. So yeah, the name, how we find it in the scene, etc. Yeah, for this one, we don't really serialize anything because by choice, like Unity kind of like takes care of the default Unity components. Like they actually keep their data. So I didn't want to like
that is a great point, that you're not trying to capture all of Unity's mono behaviors since it's already doing it. Your objective is to add on to it. So you're only putting in the stuff that you're custom building.
Yeah, exactly.
Okay, nice. That's a good workaround for it. I like that.
Yeah, because actually, like if I didn't do that, there's actually some other like weird properties that aren't really shown, like int putter, like pointers, like int pointer to some like internal like Unity related stuff that we definitely don't want to touch. So I just filtered everything and just like tried to take like the what's it called, like the properties that like either exposed by the user or like we get from inheritance. That's it. I'd like to limit it like as much as possible. So yeah, and here, as you can see, these two properties, the tick counter, like which is supposedly not serialized, is saved. The current timer is also saved, and also the text message, which is definitely not supposed to be saved since it's like an interface. As you can see here, it's like I think it doesn't have any like values related to it. That's why it's like empty, because it has a method, and we don't serialize that. Whoops, sorry. So yeah, we just mark the type, and the serializer will take care of it. And this instance was like a text message too, so we just save that value. So yeah, I guess it would be a bit tiresome to go through all this file, but I guess this like part shows exactly like how the serializer takes care of things. Yeah. So this is how the data is like represented exactly before like we do the reload. We recompile. We take a snapshot, and yeah, one more thing. All the way at the end, I keep like a static data where like I iterate over the whole assembly, and the classes that are marked with this attribute, like be hot reload static are like the ones that are taken into consideration, because I don't want to like scan everything really and just like reassign everything. That would be like that would really slow things down. So like
Right.
if a class is marked with this, I just like this example is like static counter. So
Are you by any chance checking multiple assemblies, or are you just checking the assembly from the code that's basically executing that at the time?
oh no,
Like,
multiple assemblies. Yeah.
Okay. One thing that I'll call out on this, and maybe
Mhm.
this has changed, but HoloLens, for instance, Windows, or what was it, .NET Core,
Mhm.
does not support loading the list of assemblies inside of Unity. So if you try this on HoloLens, for instance, getting the
Mhm.
list of assemblies will fail. Now I know that a lot of the systems support that, but I don't know what that separation actually is. But I figured I'd just call that out. So
Yeah, absolutely.
yeah, to anyone who's going to try this, by all means, test it first on your target hardware to make sure you can actually get the list of assemblies. However, if you're not splitting it into multiple assemblies, or even if you are, as long as you have code in there that triggers this somehow, you should be just fine if it's just paying attention to its own assembly.
Yeah. Also, one more thing, since like you mentioned that this code is absolutely not production ready. This is just like a working idea. Definitely not like the source for. I'm not like a point of reference when it comes to making serializers or everything. It's just like basically went with my gut feeling and had something that worked. So feel free to criticize the code or to add something if you see if you have like some suggestions or anything.
So far, the two key things, like one is that I don't really have any criticisms on this at all, constructive or negative. But it feels a little potentially complicated. Like for one, there's a huge
Yes.
number of classes in here. Now, is this your code right here? Like where we're seeing the property filter, the converters, the filters. This is all your custom code for executing this.
Yeah, this is basically the core the custom serializer. Everything under BJSON is the custom serializer.
Okay.
It's not pretty code. It's not like it's working. It's actually like pretty organized here, but it's one of those things that like it's I think it's more beneficial if you like get how it works, go implement it on its own. But if I like show you the code and scroll through everything, it would like scare people off instead of like actually explaining, because it's just like yeah, it's just like lines of code that even if we read through them, we like lose the actual like goal of what we're doing. You know, I can go into explaining it if you want.
I'll add this caveat to anyone who's listening on this, that your architecture does not matter how awesome it is or how horrible it is. It's the end product that matters. If it works, if it does its job, great. If what really matters is the user's perspective at the end and an understanding of any expenses that you're going to incur because of the architecture. But in a lot of cases, like I've seen some absolutely horrible architectures that worked perfectly, did exactly what the user wanted, and then I've seen dozens, maybe even hundreds of architectures that looked pristine. They were perfect. They were great. And then we had some feature that basically destroys the whole thing. And we just can't build what the user wants without destroying the architecture.
Mm-hmm. Mm-hmm. Yeah, absolutely. So yeah, I think that was like a small summary of what how like the capturing of the saving of the scene data and like putting it back works. Basically, like serialize the scene, save it into like a format that you can read and like read and write to.
Mm-hmm.
Like save the scene, wait for the reload, and then yeah, just like quickly here.
That right there, that feature where you've got it right there with the assembly reload events, that is a new one for me. Yeah, I was using the serialize and having the objects handle it directly, but this is great.
Yeah, absolutely.
How were you actually triggering the execution of that static class to start out with? Did that have like an execute? Oh, initialize unload. Got it.
Yeah, absolutely. Yeah. There's the constructor and like rewire the events, and yeah, Unity should take care of this.
That is awesome. Okay, so then that is taking, there's something inside of there. It's executing, it's listening to those. Okay, so handle after assembly. You're getting the JSON file, you're doing the stream reader, reading it to end. Got it. Okay. You're getting the snapshot. So you're rebuilding your snapshot of all your scene data.
pretty
and
much.
then you are populating from JSON. Okay.
Yeah, just like basically, I think this uses the same terminology from Newtonsoft. Like Newtonsoft has like two methods. It's like toJSON or populate from JSON. Like toJSON basically creates a new instance of this. But since in our case, we already have the scene here like created, we just want to like, let's say, re-inject the data into it. Like we already have the component here. We just want to like re-inject the data. So I use, let's say, a populate, let's say populate instance, for example. Since like we really don't want to spawn another like scene, we just have the scene already created, just like load the state into the objects, and that should be it, pretty much. So yeah.
I really like this approach. There was another person who I had just gotten off, I had just talked with, and just gotten off a call with them a couple days ago. We going over something similar to this, but theirs was serializing the entire state of the game. And it was a different approach. Like they still had to write the code to serialize, to choose what all data they wanted to serialize, rather than being able to take advantage of some of these existing features. And it provided a nice value where the state of your game was actually saved in entirety, so you could actually record multiple states and step back to it. That being said, it takes extra work. In this case, because the Unity is actually handling your game objects, I mean, this is kind of a great separation of where different places might want to deal with their code. If you want to be able to jump back into the code, into previous states of the code, that was that other video. This one it honestly looks a lot lighter for the amount of work it would take to set up something like this versus the other one.
Yeah, and also if you really want to do what you mentioned in the example, you can just re-trigger this every time, and just like instead of listening for like assembly reload events, you can just trigger this manually. Let's say like
have a tool command, a menu command.
I'm sorry.
Oh, have like a menu command for it or something.
Yeah, or like have a script that like I don't know, records the scene every like X seconds. I think if I understood correctly, that's what the solution that you mentioned did, right?
Yeah. One feature that I would talk about that I'm wondering if you have a method on this. And this other one did, because of the way that it was written, but I think it takes a little more work than this. Where they could actually save the state from the client side. I'm unaware of any way to specifically save the scene inside of the from the player side for saving the scene, because your code is partially dependent on that. Now, I'm not saying there's anything wrong with that. I don't want to try emphasize. I don't want this to come across like that. I think this is absolutely awesome code. I just wondered if you have something in there, if you know of a way to do that.
To be honest, this should be doable, because I'm not really like, other than these like these three events that you see on the screen here, I'm not really depending on like other like Unity editor stuff. So if you take this whole system and just like, you know, save to JSON and read from JSON, which should be like doable client side too, I think you should be able to do the same thing, just like restructure, let's say, the things that re-trigger the scene snapshot thingy, and it should work. I haven't tried that, but theoretically, I'm not really bound to the editor in any way other than these events. So it should be doable too.
Awesome. Yeah, and okay, cool. This is so I really like finding this. Like you were talking to me today, and honestly, I love the fact that this is taking advantage of what Unity is already doing and just calling out the separation on that. Unity is already going to handle its part, let it do its job, and then we have an added serializer on top of that.
Yeah, sits like exactly on top of Unity serializer. Like before reloading, you take your data, you serialize, you let Unity do the work. After, Unity will try to reinstate whatever like Unity components it has. Then you come after and, let's say, like add the extra layer of data that you want. And there shouldn't be like any clashing between you and Unity data, since like in this example, we don't touch most of Unity's components. So yeah.
It seems like a really strong value of something you could add on this one would be adding a function event. So basically, another attribute that would be on a class after you deserialize the content back into it to re-trigger. And maybe you already have something in there, but effectively to let it reinitialize. So just like Unity is making its connections, rehooking up the objects when it's done with the deserialization, maybe something in yours is talking to a web service or talking to a database or a file or something that it has access to, and they're keeping an open connection. And so by triggering that command, it can now rewire itself, because a database connection obviously is not going, or an API connection is obviously not going to be maintained when you serialize and deserialize.
Yeah, absolutely. I think like a WebSocket, having like a WebSocket like client open, just waiting for events, and through that we can like retrigger this. It should be like absolutely doable. Yeah.
Nice.
Mhm.
Okay. Yeah, I definitely really like this. So I'm trying to think if there's anything in specific on this that I'd be interested in seeing. So initialize, unload, or do you have other things in it you want to show?
I think, to be honest, like the rest of the thing is just technicalities that are like mostly like related to serialization, and nothing that would be like really interesting architecture wise. Just like take the data, spit it out in the file, then get it back and reinstate it back into the instances.
Okay.
Yeah.
One thing I would suggest as an alternative, not for the whole thing, just for this top part where you have the private static strings up here with the paths, put in one, just have like one and have that one get loaded. And it could be a scriptable object or whatever, but it references a static spot where that's always going to be. And then inside of that, that has settings inside of it. So you can decide to change where your reload settings are coming from. Or alter where those are so that you can change it out with different test data or something in the middle of a project.
Yeah, actually, yeah, this was just done in a hurry. I have already like made my own solution for like scriptable singletons, like here.
Oh,
I don't know
and
if
I
you
see
see the
socket
example.
config in there.
Yeah. Yeah, just for testing my like some multiplayer like custom networking. But yeah, for example, I have like this singleton scriptable object that I created, where like basically if I create any class, like for example here, I create like a context manager system, I inherit from this and pass the same class like here. I have like an editor somewhere that like listens on reload, same thing. And like if I have like a new type that inherited from this, the system will automatically like create a singleton scriptable object for it. So like for example here, all these ones are like automatically created by Unity. I just need to like, all I have to do is create a class that inherits from this like singleton scriptable object, and Unity will take care of like spawning the thing. And here, all I have to do is, let me like look for an example where it used thing. Yeah, do this class.instance. After that, we will be like stepping into the scriptable object itself here. So yeah.
Okay. I definitely like the fact that you're also using a lot of generics in there for your serialization tools.
Oh yeah, absolutely. I definitely don't want to rewrite like JSON serializers. I had actually a ton of bugs that were just caused because like I forgot to write like a closing like brace or something that would really like break the whole serialization thing. So the more reusable code, the better when it comes to that.
Awesome.
Also, yeah, I don't know if you if I should like really like keep blabbering about serialization, but one more thing that I'm planning to add here is to actually serialize the events themselves. So like if like instance A is listening to event on instance B, I should be able to keep that reference, and then after like Unity's done serializing, I should be able to like relink that event subscription, let's say, so that we really keep everything. Like stuff like this, we should be able to keep after serialization. It's not implemented at a point, but yeah.
That might be a point where you don't necessarily need your code to do it, but similar to the solution that I had in mind, where we use the iSerialization callback receiver to pull those listeners back. However, that's not going to deal with this case where it's initialize on load and you reload all these events. Oh yeah, so the B hot reload, does this run? Yeah, this would run because it clears the state, it clears the assemblies. And so obviously it has to execute this. But I don't honestly know. Does it execute like the B hot reload again every time the assembly loads?
No, actually no, because it checks. Where is the thing? Because I did like a small check here. Trigger hot reload. Let's see. Okay, if it's enabled, if it's debug mode, if it will enter.
Well, if anything interacts with this, I mean, it's going to call the static constructor anyway. So you will get those events back.
Yeah, but like the goal here for now, I think it's just enabled because I was like basically testing and I didn't want to like start the scene, like play and then re-import. I just did it like for testing purposes to just like recompile and test, recompile and test. But yeah, actually should be able to just like listen here to the play mode state changed and only like and only trigger the thing where like when like the state is equal to like yeah, exiting like play mode. So it's like if we're exiting play mode, that means like we're interested in like enabling hot reload. If we're not in like exiting play mode, then don't do anything. So this should like prevent it from like reloading for nothing, let's say.
Okay.
I don't know if that really answered the question, but
I'm not positive entirely. It's kind of a little hard to fully track it down without having like debug points and actually just testing it, which is a little hard to do when it's when you're talking about between assemblies as it reloads and executes it. But whatever the case is, you did rerun that multiple times on yours, and I saw that run, and so by all means, it appears to be working exactly as it's supposed to. Yeah. Scroll back up to the hot reload, the constructor. Okay, so one thing is like you are connecting to the event handle after assembly reload. That works. It's obviously working, and the thing is that this would get cut out. This would otherwise.
Oh yeah, okay, yeah. Now I understood. Yeah. Of course. Now I see what you mean. Okay. Yeah. Since like everything is happening in the initialize on load, it's basically like getting the events correctly. Okay. Yeah. Now I see what you're saying.
Okay, it's a good call. I want to make that call out in specific because that also means that we might end up having duplicate state. If a user comes in to make modifications inside of this method to activate or configure pieces of your game state, not just the events, you might actually be duplicating certain pieces. Like for instance, if this command is loading up, making sure that certain game objects are enabled or adding a game object to monitor things or something, you might end up with a duplicate game object then because this apparently gets executed twice or every time that it does the reload.
Well, let me see. I'm not sure if I understood correctly what you mean by like having duplicate code objects. Like, can you give me like a certain scenario where I can like?
So let's say that this is initialize on load. So let's say that you're doing this and you have the initialize on load and it's you have it with a parameter for after scene loaded. And so that allows you, that would mean that you could construct a game object. This is one of the places where you might say, okay, we're going to make sure that we have manager classes in here, or a logging class or something else that we put in there.
I see. Okay. Yeah.
So this might.
So like if another class wanted like to instantiate something and it happens like between like the callbacks, is that it?
Yeah.
I see. Yeah. I didn't really like think that much about like how this could like interfere with other like initialize on load, to be honest.
Not a big deal, but that's one of those things that I think is always important for anyone who's developing these to pay attention to. Like anytime I'm doing this, I try to make sure I have kind of a map laid out of this gets called, here's the timing events, just like that Unity map where somebody who joined Unity finally just created a map of here's when the update gets called, here's when start gets called, awake, when load on initialize, etc. And they've got like all of that mapped out to see where it all runs. And it's incredibly valuable on these things just to kind of call it out in your own stuff to identify what the order of events are. Because that's going to be one of those almost impossible places to debug when it does.
This is
go wrong.
exactly why I said it's not like production ready, because having these kind of bugs like in production, like when you're like, I don't know, like last 3 months of production would really would make you want to like to pull your hair out. So this definitely not something you want to deal with on production.
Now, I will call. I want to call out one other thing because I made an assumption on what I just said as well, that the static bhot reload is happening. It might not actually be happening, and I'm very curious about this from the Unity side. Either A, it's re-executing the bhot reload, and so it rewires up the events that way, or B, Unity during the serialization recognizes that these events were tied to something, does its own serialization of those particular events, and then rehooks it up during its deserialize. That might be another thing that happens.
Yeah, as far as I know, like Unity really does like a full cleanup of like of event subscriptions between like assembly reloads. So you really lose everything like that's done here. So that's why like you need like to rehook everything you do on like initialize on load, as far as I know. So yeah, I don't think Unity really like saves your event subscriptions between assembly reloads. That's why we have to like rewire everything.
I do see the risk though. It's like on after assembly reload, when does that execute? Because on initialize on load, for instance, that one, can you hit the parentheses on your on line 16 for?
Yeah. Line 16 here.
Line 16. Yeah. I had a parentheses at the end of load, just so we can see the attributes. Because that.
Oh yeah, for like the yeah.
Yeah, I can't remember what the other.
Oh no, I think you're talking about the. I think you're talking about the runtime initialize on load. This one.
Yes. Yeah, that was it. Okay.
Yeah.
Initial. Ooh, what's the difference between those?
This is runtime. This gets called on scene reload. Yeah, but this one initialize on reload is just editor. If I'm not mistaken.
Okay.
But yeah.
No, that makes sense. Awesome. Okay, so on the editor that executes that one. Cool. I didn't realize there was a second one, and I saw the method, and I was just remembering. I knew what that was, and great. Okay.
Yeah, this one's like I know it's like for like scene loading stuff and runtime related stuff. Yeah.
Yeah. Okay, so cool.
Really,
so that one just happens on editor. It's probably re-executing again, and that means that this happens before the actual reload event, the assembly reload event. It went like before it does the after assembly reload. That's when it does the initialize on load command, so we can wire up and listen to those. However, that's theory again. One of the things that I've had to do in this stuff to actually track down like the orders of events is put in file saves where I literally have it save files, and each one has another index or another number, and it loads up a file to get the number, grabs the number, saves it back into stored at another level, and then loads it up the next thing and starts saving out this long thing. And it was kind of crazy because there's a few points where it seems obvious that events operate in a certain order, but it's hard to be sure when these things are getting cut out and reloaded. So I was questioning that, but I think you're right on this. I would default to agree, but I always prefer calling out the areas where I'm actually not sure.
Yeah, and actually, yeah, about like the rehooking of events, like the before and after, they don't get like called together at the same time. Like Unity doesn't really like spit out all the events at the same time. Like it apparently differentiates before like the before and after assembly. It's not like on reload. It's not like generic. It differentiates before like the before and after. And yeah, apparently like there's nothing that will be like triggering twice here. So like the order of execution between these two events is pretty much guaranteed by Unity.
Also, I haven't seen that. I haven't seen that setup before of specifically subtracting yours as well to remove it as like a safety measure before it actually executes.
This is just muscle memory because I've seen some like I don't know if you debugged like before, like I don't know if you like made the mistake before of like subscribing twice and you try to step into the debugger to see what's going on. It's a nightmare like to even realize that like you stepped twice. I hate doing that. So I just like, as a safety measure, just to avoid the headache. Like, to be honest, in this case, we probably don't need to, because the assembly is like refreshed, so everything's like starting from a clean slate. So we don't really need to even unsubscribe, because everything is starting like from point zero. But yeah, just like a muscle memory thing that I always
Yeah,
do.
for the exact same reason, I'm usually just really careful about making sure that things are unsubscribing themselves to the proper states, and then so that I can trust that state. But in this case, actually putting a minus, I never thought about doing a minus beforehand. I never tested it, and I just kind of assumed that would probably throw an error. But clearly, it's not. So
Yeah.
I'm probably
No,
going
yeah. I don't know if you like looked into the inner workings of events, but they're basically like the plus and the minus. Apparently, like the event basically stores the references to these methods in like a linked list. So basically, this is like pretty much doing like add lambda and remove lambda. So that's pretty much what it's doing. So if it exists, it will remove it. If it doesn't exist, so it will do nothing. So if you really, really want to be careful,
nice.
you can just like remove just in case, and yeah.
I think that's a great practice. I like it. I'm going to keep
Yeah,
that
I'm
in
pretty
mind.
sure. I'm pretty sure this already saved me like hours of like debugging that I would have spent like just tracking events in the editor. So yeah.
Awesome. Okay, so yeah, so far I definitely like your approach to this. It kind of depends on what I would be doing jumping into a game as to which system I want. Right now, I'm defaulting to the runtime to the iSerialization callback receiver to just rewire statics and kind of conform my architecture to Unity's component system, but and scriptables.
Mhm.
But there's definitely a lot of value because this one allows you to start pulling in more third-party layers. For instance, there's been multiple projects I've been on where we have a list of objects on how our communications work, how the streaming works, and then all of those different things have to be available. But it's not just for Unity; it's for Unity, it's for a C# app, it's for a Silverlight. Well, not Silverlight anymore, I don't think, but for some form of other app. But we needed different systems, so we're pulling in a DLL. This type of setup would allow us to tie in more of those data, like the MVC component structure, MVVM component structures, into actually getting serialization out of Unity. And I think that's pretty awesome. So depending on the project this is going for, I think there's a lot of value in pulling in something like this.
Yeah, because the solution's pretty much how should I say it, like structure agnostic. Pretty much, you just everything you put into the serializer is like these like the root objects in the scene, and it just keeps recursing down until it like hits like a leaf node. So pretty much it's not for like only like Unity specific. It's just like you just pass it objects, it keeps recursing and serializing. So yeah, I don't see a reason why it wouldn't work with pretty much anything C#. Like I didn't really try it with some non-Unity stuff, but I'm sure like if you want like to track the state of anything, pretty much you can just like pass something into it, it will just keep the state and then it can reload. So yeah, I can see that point, how it's not like only like Unity specific. You can like work on any like other external classes or anything that you import into the project.
This is pretty awesome. I think this would probably make a good asset on the asset store. If there isn't already something there like it, but I don't remember seeing something like this.
I think there has been like a solution that's no longer available in the store. I've seen like some people posting links to it. That's like
Yeah,
a solution that took care of. Mhm.
I know there's like save. There's a Unity. There's a save system. I can't remember what it's called, but it just has like a picture of a 3.5-inch
Easy
floppy disk.
save,
That's
easy save,
probably
I
it.
think.
Yeah.
Yeah.
And I haven't taken too much of a look at the details. I usually when I'm doing this stuff, I prefer not using other people's assets for them, just because of the fact that I can't choose to release the source code if I wanted to. And I usually
Yeah.
prefer having that.
Yeah. I think I worked also on a project that used easy save, and it's actually not like easy save doesn't really concern itself with like scene state and static. It's pretty
Mhm.
much just takes like stuff that implements the I savable. This is like an interface that it exposes, and just takes care of saving that, no more.
Oh, okay. So
So
like
it's
your stuff.
it's pretty much like it pretty much concerns itself with gameplay stuff. So like to make your own like load game, save game systems, that kind of stuff. It's not really like it's not concerned with taking a whole like global snapshot.
Yeah, and since you've already been playing around in this area and found these particular events, I figured I'd also ask, do you know a way that during the serialization, you can get access from C# to the state or the serialization data that Unity saved? Because being able to get access to that and then manipulating it, that might be a really interesting way to deal with a lot of
Oh,
things.
you mean actually like serializing components, like
Yeah,
actual
so when
game
it does
objects?
yeah, like when it saves a scene right before the assembly where it unloads, and so it unloads your assemblies after it serializes all that data. I've never seen a way to actually get access to its serialized copy of the data. I mean, I assume it's binary for one, so it's not going to be straightforward.
I'm sorry, did you mean like the data of the scene?
Yeah, but specifically though, not for the scene save on this side, but the however it's going to do it when the system reloads, because it seems like it just does it, stores it in memory. It's most likely going to be binary, not strings, because that's going to be a lot faster. So that I'm curious about that, and I've been hoping there's a way to do that, and I've never found it. So I just figured I'd ask.
I'm still honestly not sure about like the question exactly, but like, are you asking about if there's a way to get the data of the scene during runtime? Is that it?
Yes. Yeah.
I'm not really sure. Like the tricky thing about like scene like layout specifically is like it uses, I think, what is it called? YAML.
There's the YAML. Yeah.
Yeah. So it's not really like
But
something that you're.
but YAML is also being done for the file side storage. Yeah, that's right. And I'm not necessarily, I doubt that that's what they would use for actually loading the content. I assume it's actually a full binary save, and if I remember right, it defaults to binary saves now. So actually that might just kind of match with what that structure is, but anyway, not important. It's just one of those things that would open up some new doorways if we could get access to it.
Yeah. To be honest, I'm not really sure about how the scene is actually represented like during runtime. And I think actually the like Unity tends to separate the editor scene representation from the runtime like a lot. I think that's pretty much what's happening when you press play. Like there's no like during runtime, there's no concept of like prefabs. There's no concept of like prefab variants. It's just like takes a copy, like an actual copy, and like spits it back in the scene and turns play. So a lot of like metadata is lost when you try to look at the scene during runtime. I guess Unity like strips out everything that's like extra that represents like extra info about like the prefab or like editor state, and just turns it into game objects and components. That's it. So as far as I know, that's like how Unity handles like scenes.
Yeah. I figured I'd just ask in case your explorations have led you somewhere on that. Anyway, so out into YouTube land, anyone else who, if you happen to have seen that would be awesome. Please comment on that and what you found. Otherwise, any other thing that you want to ask about this or talk about, please add to the comments.